CIT 1122 instructional video packet tracer 345. Same layout as last video. And really, we kind of did this in the last video, but we're going to add one more piece. We're going to talk about native VLANs in this particular video. The thing that was left out in the last video, where we put this together and we got 3 switches, and there's 2 of the switches are populated with PCs on 3 different VLANs, and then they're connected to an intermediary switch in between. And what we needed to do at the end to make that one work was set up the gigabit Ethernet links on the switches for trunking. And we just did that really quickly. We just did switch port mode trunk. We're going to do the same thing in this one, but we're going to add in another element for the native VLAN. So when they talk about the native VLAN is the traffic that passes across the switches that is untagged. Remember that when we do trunking, we have to keep track of the data and figure out from which network it's on. Now, the downside of that is switches don't keep track of networks. Switches keep track of MAC addresses, and switches keep track of ports. So in order to manage that, switches take ports, put them into port groups, and then call them VLANs. And then switch interfaces that are in the same port groups can be in the same VLAN, and that's all well and good. And then when you run across the trunk link, where you're going to run traffic from different port groups, into another switch, the other switch has to figure out, well, what interfaces should I send this particular message out? And the answer is it reads a tag called an 802.1q frame tag, which basically just has the VLAN ID in it. Now, the native VLAN is by default VLAN 1, and that's the default VLAN for every interface on a switch. And what we want to do to make the switches more secure is move the native VLAN off of VLAN 1 so that untagged traffic cannot float aimlessly through the system. It will have to be specifically coming from a VLAN that you make the native VLAN. In this case, we're going to make it native VLAN 99, and then we're not going to use it for any traffic. So all of the important traffic, all of the traffic that we send across the switches will be traffic that is tagged and will only go to the correct port groups, aka VLANs, that we just so choose. Hopefully that makes sense. All right, so very simply, this is a pretty fast lab. Display the current VLANs. So to check a VLAN on a switch, we can pick any switch. I guess we'll pick switch 1. And if we want to look at the VLANs here, it's en and then show VLAN. And it'll show the VLANs that are configured here. Now, this is a little tricky because all of the interfaces on this particular device are still in VLAN 1, which is kind of a security problem anyway. But the other VLANs are created. 10, 20, 30, 88, 99 are all actually here already. Okay? So one of the things we would do in addition to this, if this was a security lab, is we would take all of the ports that we're not using and we would move them out of VLAN 1 and move them maybe into a different VLAN and shut them down. So just keep that in mind, and we'll move the native VLAN also into VLAN 99. So, all right, we've seen that. Let's go to step 2. Switches 2 and 3 display the VLAN. Yeah, close enough, right? We can do switch 2 will look a little bit different. Show VLAN here, and this does look a little different because although some of the ports are in the default VLAN still into VLAN 1, some of the ports are in VLAN 10, 20, and 30, which we want to allow to communicate with each other. And the way we're going to do that is we're just going to set up those trunk ports. So these switches are totally set up. This is just like you just finished the lab from 3.3. 3.3.12 just ended, and boom, now here we are. All of the interfaces are configured. The VLANs are set up. We just got to do the trunk ports. So let's do it. So let's get down to part 2 here. And we're going to get into configuring trunking on switch 1. So let's go to switch 1, and we're going to do these 2 commands. We're going to do switch port mode trunk and switch port trunk native VLAN 99. And we're going to apply that to both G interfaces because they're both trunk links connected to different switches. So config t int range G0/1-2 and switch port mode trunk. Great, puts them in trunking mode, and we change the native VLAN now to native VLAN 99. So switch port trunk native VLAN 99. Perfect. All right, guess what? Boom, we just did it. Now here's the thing. Trunk links, when they're set up and they're functioning, they talk to each other, and they're like, hey, are you a trunk link? Yeah, I am. Okay, good. Hey, let's trunk some traffic back and forth. Cool. Yeah, I think this is a great idea. What's your native VLAN? My native VLAN is VLAN 1. What's yours? Oh, man, mine's 99. You know what? This is configured wrong. We should let the administrator know that this is jacked up. And we should tell them, like, every 15 or 30 seconds that this is a mistake. So when you have a native VLAN mismatch, just means that your native VLAN command, the one that we just added there, switch port trunk, native VLAN, whatever, is different than the native VLAN on another switch. Like, for instance, switch 2 and switch 3 still believe the native VLAN is VLAN 1, so we're going to get some error messages, and we're seeing them over here as well. So let's go ahead and fix that. So config t int g0/1, and this would be switch port trunk native VLAN 99. And that's looking pretty good. And now we're looking good, and it says, hey, that's restored, so we like that. And let's go over to switch 3. Let's do the exact same thing. And intg0/2 on this one, and that's going to be switch port trunk native VLAN 99 again, and we're set to go. And that was the world's fastest lab. So hopefully you like that one. The next one coming up, we're going to go deeper into trunk links and the specifications of doing more than just setting them up as trunks. So look for that.